We've now seen that there will be many more releases of Java in the future. Traditionally, there have been two kinds of JDK releases, the one done by Oracle itself and the one released from OpenJDK. The Oracle JDK always builds off OpenJDK itself, but adds additional closed source features. You can think of, for example, alternative garbage collection implementations, or a custom and closed source rendering engine for GUI applications, as was the case up until Java 8. But with the release of Java 9, Oracle has indicated that it's going to unify the Oracle JDK and the OpenJDK. Their goal is to align these code bases, so that ultimately everything will end up in OpenJDK. The end goal is that the Oracle JDK builds and the OpenJDK builds will be identical. The first steps toward this goal have already been taken with Java 9. In Java 9, the proprietary and closed source graphics rendering engine has been replaced by a superior open source implementation that is now part of OpenJDK. Going forward, Oracle has committed to open source all the commercial features that are part of the Oracle JDK and to contribute them to OpenJDK. To give you an idea of what kind of features these are, here's an overview. One example is the Java Flight Recorder functionality, which is currently only available in Oracle JDK if you're using a commercial license. Java Flight Recorder features an always-on recording feature of all telemetry inside of the JVM, which you can retroactively inspect after some runtime failure happens. Another commercial feature that will be open-sourced is Java Mission Control. Java Mission Control is a collection of advanced tools to analyze recordings of Java Flight Recorder. So these two taken together will really improve the story around debugging and analyzing failures in JVM. Another feature that hasn't been open sourced yet by Oracle is the Z Garbage Collector, which is a garbage collector aimed at extremely large heaps, while still offering low latency and high throughput. A last feature that will be open sourced is the application class data sharing feature. The good news is that this feature will already be open sourced with Java 10, so it will be part of OpenJDK 10. We'll have a look at application class data sharing in the last module of this course. It will take some time before all of these commercial features have been ported to OpenJDK. However, it's expected that most of the convergence between Oracle JDK and OpenJDK will be completed by JDK 11, so that will be the release of September 2018. There are no firm commitments on this, but everything seems to be moving in that direction. Supported binary builds will be available both through Oracle and the OpenJDK infrastructure for Linux, macOS and Windows. Note that by default only 64-bit builds will be available. All OpenJDK code, which these builds will be based off, is licensed with GPL version 2. Note that the number of supported platforms, as shown here, has decreased if you compare it with what was available in Java 8 times. Most notably, there are no 32-bit builds and there's also no build for ARM devices. However, keep in mind, these builds are only what is promised by Oracle. There are other parties involved in OpenJDK as well, for example Azul, IBM, and even a community effort called Adopt OpenJDK. These vendors all plan to support their own builds, based on the same OpenJDK codebase. For example, Azul currently does publish 32-bit builds, and also builds for ARM embedded devices. So if your platform isn't part of the default supported builds by Oracle through OpenJDK, then you should definitely check out one of these other vendors, who publish builds for different configurations. One last example of the convergence of Oracle JDK and OpenJDK has to do with security and certificates. If you were to build the plain OpenJDK sources and use that as a JDK, you'll run into an issue when you want to establish secured HTTPS connections. Because in order to verify the validity of certificates, you need to have the root certificates that represent the certificate authorities, like for example VeriSign and other big certificate authorities. Browsers, for example, have these root certificates embedded so they can create secure connections to websites. Now if the JDK wants to set up a secure TLS connection, it also needs these certificates. In the JDK, these root certificates should live in the CA search file. However, in the OpenJDK codebase, these certificates are not there. That's because the certificate authorities all have a signed agreement with Oracle rather than OpenJDK to exchange certificates. However, currently Oracle is in the process of moving this root CA program to OpenJDK. That means new agreements have to be signed with all certificate authorities, indicating that the certificates may now be part of OpenJDK under a permissive license. In OpenJDK 10, the first certificates will already appear. However, not all parties have signed a new agreement yet. So this will be a process that takes time and won't be completed with JDK 10. If you want more details, have a look at JEP 319, which contains more information about which certificate authorities have already signed the agreement and which haven't. In the end, the goal is to have all relevant root certificates as part of OpenJDK as soon as possible.